Hi everyone, welcome to our presentation for our CSE 163 final project, Predicting NBA Team Performance with Machine Learning in Python. My partners are Joseph and June, and I'm Lucas. Our motivation to start this project was because basketball is a very complex game, and even though stats are important, they can only capture small aspects of it. However, analytics, or using data analysis to make strategic decisions, is now dominating the NBA. One example is how the Houston Rockets, under general manager Daryl Morey, almost exclusively took shots from three-point range or next to the basket because they are statistically the most efficient. We wanted to try our hands at analytics to learn about the advantages and disadvantages of this perspective.
Hi, I'm Joseph Boone. I'm going to be presenting our research questions. And so our first one was how can we use metrics to predict season standings? Our second one was how can we use recent game team performance to predict the outcome of a game? And attached to that was what are the most effective statistical features for predictors? And finally, our third one was how does the difficulty of a team schedule, specifically the number of back-to-back games, affect the winning probability or outcome of a game?
So the methodology for predicting the standings, we first joined two data sets called team per game stats and season standings. Then we made this joint data set for each season and eventually combined them for the last decade. And after our data set was ready, we trained our data using decision tree classifier. And for the feature variables, we chose this most fundamental statistics in the box score because we wanted to know how much accurate the model can be with only using this basic box scores. And then we tested it on the ongoing current NBA season to make predictions. By the end of this step, we were able to make prediction on the standings, but the predictions varied wildly whenever we ran our model. So this is why we had to run our model multiple times and average the predicted standings. Our result was not exactly the same as actual standings, however, it still made notable predictions. For example, teams like the Suns, Nets, Jazz are actually the teams that are currently in top five, and the Rockets, Pistons, Wizards are actually teams that are in the lowest five. And then we visualized this result on how much difference the model made for each team. And by this visualization, we were able to know how much accurate our model predicted for each team.
Next, we trained a decision tree classifier to predict outcomes of single games based on running average statistics from recent games. Our code used statistical game logs to generate a new data frame with average statistics from recent games for each game. To use as the features, the labels were the win or loss outcome of each game. We assessed the performance of the model when adjusting the window size parameter and maximum tree height hyperparameter, and assessed the importance of each feature in the trees over many model iterations to account for variation. We found that adjusting window size did not affect training accuracy, but testing accuracy peaked at a window size of 10, showing that the 10 most recent games provide a good measure of the team's form. When increasing maximum depth, training accuracy rose, but testing accuracy actually decreased slightly after 2, showing that the model is prone to overfitting. Finally, we found that in models, the most important predictive features from recent 10-game average performance included defensive rebounds and turnovers, while the least important ones were days since last game and recent game win percentage.
And so our methodology for the scheduled difficulty effect evaluation was first to calculate and gather the top 5 and bottom 5 teams from any single given season. And then we would get the game log data for each team from that season and then proceed to calculate all back-to-back game stats for every single team. And that includes the number of back-to-back games, back-to-back game win percentage, as well as regular or also known as non-back-to-back game win percentage. And then we would concatenate stats from every team and then calculate averages across each team and season. And then we'd repeat that for multiple seasons in order to compare different seasons. And so these are the results from our scheduled difficulty effect evaluation. As you can see, the back-to-back game win percentage compared to the regular game win percentage on the right differs from season to season. And so in the 2016-17 season, the back-to-back win percentage was about 47.6%, while the regular game win percentage was about 55.1%, a big difference. However, in the 2018-19 season, back-to-back win percentage was about 46.9%, and regular game win percentage was around 47.3%, which is a much smaller difference.
In the future, we would like to improve each part of our analysis. For the standings predictions, we would like to utilize advanced stats such as net rating, assist percentage, and true shooting percentage, which might be more effective indicators of team quality. For the game predictor, we would like to change the model to take in performance of both teams as features and output which team it thinks will win. For schedule difficulty evaluation, we would like to incorporate an analysis of how traveling affects win percentage in back-to-backs and other games.